Section 6.4 is going to get into the dot product. And what we want to know for this class is that a dot product yields a scalar instead of a vector. You've noticed so far that when we worked with vectors earlier, we were able to add and subtract vectors by adding and subtracting the x components and the y components. We were able to multiply a scalar or a constant into a vector, but there was nothing that when we multiplied a vector by another vector, we multiplied x components, we multiplied y components. We didn't do that. And in this section, the idea of a dot product is pretty close to that. The dot product is going to give us a scalar instead of a vector, which means our n value is going to be a number. And that number has some specific properties based off of the problem that we're looking at. So the first thing we want to look at is the definition of a dot product. The dot product of two vectors is represented by this big period here. And it is the dot product of u and v is equal to u1 v1 plus u2 v2. What that's saying is you multiply the x pieces of the vector, you multiply the y pieces of the vector, and then you add the results together. So right here, finding the dot product of the following two vectors, u dot v. I want to find the dot product of these two vectors, which means I'm going to start by multiplying the x pieces. I multiply the y pieces, and then I add the result. So multiply the x pieces, multiply the y pieces, and add the result. And these vectors are in component form. So the dot product of u and v is 28. And right now that 28 doesn't mean a lot to us, but what we know is that this is a scalar instead of another vector. We don't have a u or v or i's and j's in it, it's just a number. Second one, same idea, finding the dot product. I'm going to multiply the x pieces together, multiply the y pieces together, and then add the result. And this dot product is going to be negative 30. Perfectly fine that we've got a negative value there. All that's saying is that we've got a negative scalar. The second idea is we can look at magnitude of a vector as being tied to the dot product. And if we write the magnitude in terms of a dot product, it ends up being that if I take the dot product of the vector itself, I get the value for the magnitude by taking the square root. So basically, if I wanted to summarize this, it would be that the dot product of a vector with itself gives us the magnitude squared. And that should make sense based off of what we did previously with magnitude. When we're in component form, the magnitude is the square root of the x components plus the square root of the y components. Now when we take the dot product of the vector with itself, if we take x times x, it's the same thing as x squared, or if we take y times y, it's the same thing as y squared. So here in example 2, using the dot product to find the magnitude of the following vectors, what it would look like is this. With the magnitude, I am going to take the dot product of u and u. And if I look at that as u and u, let me write this as 20 and 25. And let's say I take u again as 20 and 25. Remember, the dot product is taking the x components, multiplying them together, taking the y components and multiplying them together. So if I were to find the dot product here of these two things, u dot u, it would be x components being multiplied, it would be the y components being multiplied, and then adding them together. So you can see in this case, I get 1025. So the dot product of the vector with itself gives us the magnitude squared, which is right there, the magnitude squared. So in order to find the magnitude, we take the square root. So then the magnitude is the square root of 1025. And you can see right here that this is pretty much your formula for magnitude, the x squared plus the y squared piece when we look at it in component form. So here with letter B, if I want to find the magnitude using the dot product, what I'm going to do is I'm going to take the square root of u dot u, which is the square root of multiplying the x components, multiplying the y components, and then adding the result together, which is going to be the square root of 225 plus 81, which will be the square root of 306.